Hey, how's it going? I'm going to give a quick intro to explain what this video is all about, but definitely feel free to skip ahead. Timestamps are in the description. A few months ago, I made a demo video about a bass that I customized with 5 of the same type of pickup. The idea was to find out what only position and parallel series combination made to a bass's sound. There have been a ton of terrific comments. I've loved reading about some of the custom basses that you've done, or your ideas for different mods. So cool to read. One of the comments that was made a few times was, can you post a wiring diagram of the 5 pickup bass? And the answer is absolutely. I thought it might actually be simpler to explain in a video, so here we are. If you haven't seen the original demo video, there's a link in the description. This is really a companion video to that one, but hey, if you want to watch this one first, that's cool too. I'm going to start with a brief walkthrough of a standard passive jazz bass schematic, which also essentially provides a schematic of a standard passive precision bass, since they're almost the same thing. That will give us a pretty good baseline for about 75% of all the basses in existence, since many basses really just copy those designs. Then we'll talk about the 5 pickup bass. Reason is, as different as they look, a jazz bass and the 5 pickup bass that I made are essentially set up the same way. If you're already familiar with J bass or P bass wiring, absolutely feel free to skip ahead. After that, I'll give a few lessons learned that I got from this project that might be useful if you're thinking about your own mods. Now, one note, I'm going to assume that you may have a little bit of understanding about the basics of guitar electronics, such as what a potentiometer is or what a capacitor is, but beyond that, I'll try to keep things pretty basic. So let's take a look at how a jazz bass works. Here on the screen is a wiring schematic for a standard jazz bass. The neck pickup is on the left, the bridge pickup is on the right, and from there, the pickups connect into the neck volume control, the bridge volume control, and the tone control. The wiring going out to the right side just goes out to the jack. The important part here is that the potentiometers for the neck and bridge volume are both 250 kiloohms each, or 250K. The tone control is also a 250K pot, and it's in series with a 0.047 microfarad capacitor, usually. As I understand it from the factory, sometimes they come with a 0.05 microfarad capacitor, which are almost the same, and the difference between them is essentially inaudible. So to help simplify this, I find that it's helpful to look at this as 3 blocks. There's the neck pickup and volume block, there's the bridge pickup and bridge volume block, and then the tone block. These are color-coded here on the screen, green, blue, orange. Given this, it's pretty easy to envision how this schematic works. Working from the negative terminal of the jack on the right towards the left, you can see that these pickups are organized in parallel, and the signal will flow from the negative terminal, or the ground, through the pickup, which generates a voltage, which then hits each one of the potentiometers, neck and bridge. From there, those potentiometers are just controlling how much of that voltage that's generated from the pickups gets sent to ground versus how much gets sent to the positive terminal of the output jack, and therefore what you hear as the output of the bass. In parallel with both of those pickups is the tone control. The tone control for jazz basses, precision basses, even Stratocasters, and lots of other passive guitars is a simple RC combination. That stands for resistor capacitor. When a resistor and a capacitor are in series like this, it forms a very simple but effective low-pass filter. And by simply changing the resistance value through the potentiometer, you're adjusting how much of the high frequency content is getting sent to ground and therefore coming out of the signal. So by dialing it to 0%, you're getting a very muffled, bassier tone by simply removing the higher frequencies. By opening up to 100, you're passing as much of those high frequencies as you can with this combination. Oh, and I mentioned earlier that a precision bass is very, very similar to a jazz bass. To envision how a precision bass works, just imagine the blue going away. All you're left with is the green with a neck pickup and a neck volume control, and the orange tone control. And even simpler than a jazz bass, you have a precision bass setup. Now, there is one difference about the way that usually this volume pot is wired. It's just reversing a couple of terminals, but it operates essentially the same way. So now let's compare a standard jazz bass to the 5 pickup bass. Now, I know that's hard to read. I'll show this in greater detail a little bit later in the video. Keeping those 3 blocks in mind, again color-coded here on the screen, you can compare those to the same sets of blocks in the 5 pickup bass. You'll see that really the true difference here is mainly how many pickups are in each one of these blocks. So let's take a little bit of a closer look at how these electronics work. You can think about all 5 of the pickups as its own module, and that includes not only the pickup, but the switches that control each one of the coils. Taking a closer look at one of those pickup modules, these pickups that I'm using, as I mentioned in the video, are DiMarzio Area J pickups. They are actually side-by-side humbuckers with one coil on the bass side of the strings and one coil on the treble side of the strings. So you can isolate the top 2 strings or the bottom 2 strings by controlling whether that coil is on or off. Here I'm showing the 2 SPDT switches, or single pole double throw switches, that go along with each one of the pickups. Each switch controls one coil of the pickup. So in this example here, I'm showing both pickup selector switches off. If we follow that signal path here, which I've drawn in highlighter, working from the negative terminal of the jack to the positive terminal or the output, you'll see that the signal comes through, hits the center terminal of the SPDT switch, and because it's set to off, the signal will flow through and bypass that pickup coil entirely. It hits the other SPDT switch and does the same thing and goes straight out. The wiring is connected at one end to each one of the coils. However, remember that a key principle of electronic circuits is that no current will flow unless you have a completed circuit. So by disconnecting that return path from each one of these coils, you'll see that we've essentially disconnected that coil from the circuit. I'll go into a little bit more detail about that in lessons learned at the end of the video. Now in this diagram, I've turned on the treble side of the pickup, but the bass side is still off. So let's see what difference that makes. From the negative terminal or ground, we follow the signal path up to the center terminal of the SPDT switch. This time, we go down through the other terminal, come out and go through the pickup and make a complete circuit back to the other side of the switch. And from there, we go to the other SPDT switch. That pickup coil is turned off, so we go straight to output. So you can see that by switching that one side of the pickup on, we're getting the sound or a complete circuit from just the treble side of the pickup. Now let's do the opposite. If we're going to follow this again, we're going through the treble side control, which is bypassed. We go to the bass side, but instead of bypassing this one, we go through the pickup this way and then out to the output. In this example, you can see how the bass 2 strings will be on, whereas the treble 2 strings will be off. Now finally, to be complete about it, let's see what happens when both pickup selector switches are on. We go through the switch as before. This time it goes through the treble pickup coil, then through the bass pickup coil, and then finally to the output. So you can see that by simply flipping one switch or the other switch, you're able to select if one or both of these pickup coils is on. Then just imagine this multiplied by 5 times, and you've got a pretty good idea of how the pickups work on the 5-pickup bass. Moving on to the tone control block, you'll see that this is the exact same as a stock jazz bass, with the only difference being here that I threw in this DP-DT or double pole, double throw capacitor select switch. You might have noticed that on the video. This was something I was curious to try out just to see what the difference was between a stock 0.047, or in this case I actually used a 0.05 microfarad capacitor, compared to something that would be a little darker, in this case a 0.1 microfarad capacitor. Now in the demo video, I had this set to the stock value, so again, it was exactly the same as a jazz bass. So one thing you'll notice here is that the pickup modules are arranged in groups. There's sort of the neck group of 3 pickups, and then there's a bridge group of 2 pickups on the right. This really functions identically to a jazz bass, which just has 1 pickup on the neck side and 1 on the bridge side, except in this case, there are all of these coils set up in series. So inherently within the neck group and within the bridge group, all of the pickup coils are set up in series. And you can essentially turn on or off as many of the coils in those groups as you want to. The electronics don't really care how many coils are active at once. They react the same way. Now, the one other difference between this and a jazz bass is that I added this parallel series switch, and that takes the neck group and the bridge group themselves and sets them either in parallel with each other or in series with each other. So just to recap, the pickups within each group are always in series with each other, whereas the neck pickup and the bridge pickup can be set to be in parallel or in series with each other. Otherwise, you'll notice that these modules are essentially the same. This neck pickup group feeds to the neck volume control, and the bridge pickup group feeds to this bridge volume control, exactly the same as a normal jazz bass. It operates identically. Likewise, if you're in series position here, this will actually bypass the neck volume control, and all of the pickups will feed directly to the bridge volume control, which ends up being exactly the same as a precision bass setup. So let's take a look at an example, putting all these blocks together. We're going back to the full diagram that shows the entire wiring diagram for the bass. Let's trace this coming in from the negative side of the output jack, which is also ground. We run up to the neck pickup, and on this side, we've got a switch set so that it's only the bass side of the neck pickup. Then it runs in series to the next pickup, and we only have the treble side of that next pickup. So right away here on the left, we've created a precision bass arrangement. From there, we run to the parallel series switch, which is set to parallel in this case, the same type of configuration as a PJ bass. And from there, we have both halves of the pickup that's second closest to the bridge turned on, which is in this case, the exact same position as a bridge pickup on a typical 60s style jazz bass. From there, we bypass the last pickup. Both of these groups of pickups are running to their own volume controls, just like a jazz bass. There's the neck volume pot, the bridge volume pot, and then from there connecting into the tone control, again set to the default stock value, and then out to output. Let's take a look at another example. This would be just a precision bass setting, or P bass. In this case, one difference is that we've got the series parallel switch set to series. And that's because in this case, we only have pickups from one of the two pickup groups turned on. When you do that, just because of the way this is wired up, kind of a quirk of this design is that if you have it in parallel, it'll shunt directly to ground and no sound will come out. So knowing that, if I'm going to play a P setting, I've got to set it up to series. When that happens, the signal goes directly to the bridge volume only, and the neck volume is really not doing anything in the circuit. From there, it runs to the tone control, just like a precision bass, and out to the output jack. Now, as mentioned earlier in the video, here's a view that's a bit more zoomed in. Hopefully that's legible on your screen. Feel free to pause the video here if you'd like to take a closer look. All right. So if you're looking at this diagram and thinking, wow, that's a lot of wiring connections, that must be a mess inside the bass. Yes, it is. There's a picture of it back when I was building it. But yeah, with 5 wires coming out of each one of those pickups, it's kind of spaghetti in there. I'm a little worried about so many points of failure. So far, so good. Obviously, this isn't the most practical design for a gigging bass. All right, well, thanks again for watching this video this far. I thought I would end on a few lessons learned that I came across in doing this project. If you're into guitar electronics, this might save you some time, or you might just find it interesting. Number 1, going back to this pickup module diagram, remember how I said that by disconnecting each one of these coils, we're really only disconnecting one side of the circuit. And by electronics theory, we shouldn't be getting any current flow because you need a complete circuit in order for current to flow. And therefore, that half of the pickup shouldn't be influencing the sound. Now, I was a little concerned about this because I thought, oh, that's theory, but maybe if I turn this off, I might be hearing some signal bleed through from this partially disconnected pickup coil. So I tried it out. Back when I was breadboarding this circuit, I tried this with DP-DT switches, or double pole, double throw switches, to completely disconnect both ends of the pickup coils. But I'll tell you, I was pleasantly surprised to find out that I couldn't hear any difference whatsoever. Using these SPDT switches and only disconnecting one end of the pickup circuit, I still couldn't hear anything from these pickups when they're turned off. That was great news for me because these SPDT switches fit a lot better into the controls cavity than the DPDT switches would have. Number 2, one other question that I had was, how much are the neck volume, bridge volume, and tone controls really affecting the output sound when they're set to fully on? So the tone control is on 100%, both of the volumes are on 100%. How much are those still passively sucking tone, so to speak? What I did was I tried installing a switch that bypassed all of the tone controls. It went directly from the pickup output to the output jack. Flipping back and forth between tone and volume controls engaged and having them completely removed from the circuit, I could hear no audible difference between them. That in turn kind of simplified things for me because it meant that keeping the volume and tone controls in the circuit wasn't having some kind of major negative impact on the sound of the bass. Now, if you're curious about that, I would definitely recommend trying it for yourself. See if you can hear a difference. You may have better ears than I do. Lastly, remember I mentioned I installed that capacitor select switch. Well, that I think was still a good idea, and I'm glad I tried it out. I will say for those of you who are interested in trying out different capacitor values, go for it. But what I thought was interesting about this was that I thought that doubling the size of the stock capacitor and installing a 0.1 microfarad capacitor instead of a 0.05 microfarad capacitor would make a pretty major difference to the sound. I was really surprised as well that it made almost no difference. These two capacitor values sound so similar, despite one of them being twice the size of the other, that I would have a hard time telling them apart in a blind test. So I would say if you're going to try something other than stock, you might need to go with something that's more like 5 or 10 times the stock value, whether that's bigger or smaller. Oh yeah, and something to keep in mind is the bigger the capacitor value, the more the treble will roll off, and therefore the darker the sound will be, or the less trebly the sound will be. All right, well, thanks a lot for listening. Hope this was interesting for those of you who are interested. Hope you have a lot of fun modifying your bass or guitar. Happy playing.